All right, welcome to Chapter 2, Part 2. If you remember last time we talked about bar charts or bar graphs, they're synonymous for us, and histograms. That's what we talked about last time. There's a couple more things we need to talk about, but first, before we get through this, let me ask you a review question. I hypothesize that eating cheese causes you to become obese. So the way I figure out whether you're eating cheese is yes or no. You either are or you are not eating cheese. It's yes or no. That would give me what data? Eating cheese is what kind of data? That would be nominal data because you are either in one category or the other. Yes or no. You're either eating cheese or you're not. Those are the two categories, and that's it. Okay, we need to move forward. We talked about bar graphs. Bar graphs, we measure the frequency of one categorical variable. That's a bar graph. A histogram, we're measuring or charting one continuous variable. We need to talk about a scatter plot. So this is the bar graph right here. You saw the bar graph. One categorical variable. The categories are the colors, right? So one variable color, and here's the different categories. Compared to this was our histogram, because this awesomeness is continuous data, right? Awesomeness is continuous data. So that's our histogram. It's the frequency. It's only one variable, awesomeness. Well, what do we do if we want to plot this? Now notice how no longer do we have frequency as our y-axis. Frequency is no longer the y-axis. Instead, we have age. Well, sorry, awesomeness is the y-axis. Age is the x-axis. So frequency is no longer here. We're now plotting out two different continuous variables. And to do this, we need to create a scatter plot. So to do a scatter plot, it's quite simple. All we have to do is we take the person, right? So here is ninja number 1. Ninja number 1, he has an awesomeness of 4 and age of 53. So his awesomeness level is 4, his age is 53, so we need to put him right there. Okay? His awesomeness is 4. Put him down just a little bit. And his age is 53. So he goes right there. This next ninja, awesomeness is 7. Age is 56. Oh, 56 is off the chart. I didn't even realize I had that one. So 756, he's over here. Right? He's off the charts in age. We'll just put him right there. 756. Okay? This one is 623. So awesomeness is 6, age is 23, right about there. 426, 426. 57, awesomeness is 5. He's 7 years old. He goes right there. Stay. Oh well. 57, he's right there. 5 and 31, so 5, and he's 31 years old, so he's going to go right there. Let's see if we can stand him up. Nope, probably can't. 9 and 40, awesomeness is 9, 40 years old, goes right there. 617, 6, 17 years old, goes right about there. And 1017, 10, sorry, awesomeness is 10, 17 years old, goes right there. Okay, now normally we don't just put the ninjas on the table. Instead, we put a little dot there where it goes. So for example, this guy is 5'7", right? Awesomeness of 5, age is 7 years old, 5'7", we'll put a little dot right there to represent this guy. All right? This one over here is 617, correct? 6, no. He is, he's 617. 617, 17 is there, 6 is here. Dot for him. This one right here was 1017, so let's go ahead and do 1017. Okay, notice how those are in line with each other. This one right here is 23 years old. His awesomeness is a 6, so 23/6 goes right about there. This one is 20, awesomeness of 4, 26 years old, 26, 4, right about there. This one right here, 31, awesomeness of 5, 5, 31, right about there. This one over here was 40 years old, awesomeness of 9, 40 is right there, awesomeness of 9 is right about there. 53 and 4, 4, 53, right about there. And this guy's just off the charts over here. I'll put a little, imagine a dot on my table right there. 56 and 7. Okay. This is a scatter plot. Each dot represents 2 variables, age and awesomeness. This person, their age is 7. You can tell right there because it's in line with the 7. And their awesomeness is 5. You can tell right there because the awesomeness is 5. Right? If you do a little line, boop, 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 and boop, 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 right? This person is awesomeness of 5, age of 7. Okay? This person, boop, 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 17 years old, boop, 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 awesomeness of 16. Okay? This is a scatter plot. You use that when you do 2 continuous variables. Now the last one I want to show you is a stem and leaf plot. Stem and leaf plots are not very common nowadays, but you should probably know how to do them. The stem and leaf plot is only to do 1 continuous variable. These are really kind of, anyway, they are what they are. The stem refers to the tens place. So what we're going to do is we'll do a stem and leaf plot of age right here. So this will be age. And this will be a stem and leaf plot of age. The stems represent the tens place. So anything less than 10 would have a 0 in the tens place. All right? These would be the 10s, 20s, 30s, 40s, 50s. Okay? So this is the stem, and then this is the leaf. All right? So what we do is we look here. Anybody who's less than 10, there's somebody who's 7. So there's nothing in the tens place. There is a 7 in the ones place. Stem and leaf. All right? We have 2 people who are 17, right? So they're in the tens column, right? They have a 10, 1 10, and then they have 7. So what we do is, because there's 2 of them, we separate them by commas. So this so far says that we have 1 person who's 7 years old, and we have 1 person who's 17, 2 people who's 17 years old. Right here, this person is 23, so we put a 3, right? 23. But we have somebody else who's 26. So separated by a comma, we also put a 6 right there. All right? Then we look for our 30s. We have 1 person who's 31. All right? We don't have anybody else who's 30. We have 1 person who's 40. The stem is 4. The leaf is 0. So this person is 40. We have 2 people in their 50s. 1 person is 53. And then 1 person who's 56. Okay? This is a stem and leaf plot. This is a stem and leaf plot. Now if you'll notice, by the way, if you just stick this stem and leaf plot on its side and you put little bars here, right? You get a histogram. It's the same thing as a histogram, only it's sideways, and it tells you the exact amount for each one of these different people in the different bins that you have. Okay? So what would be the frequency of 17? Well, the frequency of 17 is 2. We'd have 2 people who are 17 years old. The stem is 10, so the tens place is 1, 7, and 1, 7. 17 and 17. What is the frequency of 31? That's 1. We have 1 person who's 31. What's the frequency of 25? It's 0, because there's nobody who, we look at the 20s right here. We have someone who's 23, someone else is 26. We don't have anybody who's 25. The frequency of 25 is 0. That's the stem and leaf plot. Okay, now here's what we're going to do. Let's look at the same thing, but now what I'm going to do is let's go ahead and look at some old data that we had from before. Now, these are data from, I think it's chapter 2 that we were looking at these. But let's go ahead and look at this example right here on the screen, and let's plot it out. I'll even use the back of this so we won't have any mistakes. So these are new data. We're looking at the new data. Looking at the new data, now this time we want to know whether or not, we want to know, let's say, let's go ahead and do cups of coffee. So I want you to give me the plot of cups of coffee, just cups of coffee, from these data that we have up here. Well, in order to do this, we're only looking at one variable. That's cups of coffee right here. One variable. That means that when we plot it out, the y-axis will be frequency. The x-axis will be cups of coffee. All right? So, it's important that we keep this in order. We have 0, 1, 2, 3, 4, 5. You can go farther if you want, but that's what we're going to do. Frequency means how many times it occurs. So 0 is down here, so this is going to be 1, 2, 3, 4, like that. Okay? Now when we look at our data, we need to see what is the frequency of 0. How many zeros do we have on there? The answer is 1. Participant number 5 drank 0 cups of coffee. So the frequency of 0 is 1. So we make a little bar right there. The reason why the frequency of 0 is 1 is because one person did it. So the frequency of 0 is 1. One person had 0 cups of coffee. So the frequency of 0 is 1. What is the frequency of 1? It is 2. There are 2 people. Participant number 2 and participant number 6 both had 2 cups of coffee. So the frequency of 1 is 2. Okay? Participant number 2 and participant number 6 both had 1 cup of coffee. I think I might have said that wrong. Okay? What is the frequency of 2? Well, participant number 1 had 2 cups of coffee. Participant number 3 had 2 cups of coffee. The frequency of 2 is 2. What is the frequency of 3? Nobody had 3 cups of coffee, so the frequency of 3 is 0. What about 4? Exactly 2 people had 4 cups of coffee. Participant number 4 had 4 cups of coffee. Participant number 7 had 4 cups of coffee. So the frequency of 4 is 2. What kind of plot did we just make? We just made a histogram. A histogram looks at one continuous variable. In this case, cups of coffee is continuous because 4 is more than 3 is more than 2 is more than 1. We know this is least ordinal, so this is a histogram. Histograms, the bars touch each other. That would be a histogram. All right, on these data, which variable could I use for a bar chart? Which variable could I use for a bar graph or a bar chart? The only variable that I could use for a bar graph or bar chart is area code. The only one I could use for a bar chart on here is area code. I'll use graph and chart interchangeably, doesn't really matter. Because it is the only categorical variable on here. It's the only categorical variable. We only want the plot of one categorical variable. And so the y-axis is going to be frequency. All right? Now, what goes on the x-axis? This is going to be the area codes. Do I have to put these in order? Do I have to have 240 before 301? I don't, because it's a category. It really doesn't matter. It doesn't matter what order it goes in. It really doesn't matter. Now, I'm going to do it in order just because it seems like the right thing to do, but it doesn't matter. It doesn't matter if 240 comes before 301 or 302 or whatever else. 240, I have 301, 302, 303, and 706. Okay? The frequency is going to be 1, 2, I'll put even 3 up there. What is the frequency of 240? Well, if we look at this, participant number 3 has an area code of 240, and participant number 5 has an area code of 240. Therefore, the frequency of 240 is 2. There are 2 people who have the area code 240, so the frequency is 2. Okay? What about 301? How many people have the area code 301? Well, only one person does. That's participant 1. Now, this is a bar chart, so our bars are not going to touch each other. 302, how many people have it? Only 1. That is participant number 6, and so the frequency of 302 is 1. What is the frequency of 303? Let's count them. 1, 2. There's 2 people who have 303 as their area code, so the frequency of 303 is 2. What about 706? 706, there's only one person with 706. That's participant number 7. So the frequency of 706 is 1. This is a bar graph of area code. All right? Good. Last one. Last one we'll do is a scatter plot. Can I use area code in a scatter plot? No, I can't, because scatter plots are for 2 continuous variables. Should I put frequency as the x-axis on this scatter plot? No, because in a scatter plot you have 2 continuous variables. So let's go ahead and do our 2 continuous variables as liking for donuts. And hours of sleep. Okay? So, to be good citizens of knowledge and things, you should probably always start with 0 as the beginning, right? It's more honest to do it that way. A lot of times people cheat with graphics by changing the axis where they start and where they stop. So we're going to start with 0 over here, but let's go ahead and do 1 hour sleep, 2, 3, 4, 5, 6, and 12. Okay, good. Liking for donuts, this goes all the way up to about 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is up there. Participant number 1 slept for 6 hours. Right here. And likes donuts at a 3, therefore we're going to put their dot right here. 6 hours of sleep and likes donuts at a 3. Participant number 2, 12 hours of sleep, likes donuts at a 4. Participant number 3, 9 hours of sleep, likes it at a 2, 9, 2. Participant number 4 likes donuts at, had 8 hours of sleep, likes donuts at a 9. Now, what are we going to do about this next person, number 5? Because they also slept for 8 hours and liked donuts at a 9. So what are we supposed to do with that? Well, depends on how you do the chart. Some people just leave it, right? Some people double the size of the dot, okay? But in reality, you just need to know that there's 2 people on that same dot. Participant number 6 slept for 7 hours, likes it at a 4, 7, and 4. And participant number 7, 10 and 7. Slept for 10, likes donuts at a 7. They go right there. Now the reason why we use scatter plots is to see, hey, do people who sleep more tend to like donuts more? Or is what's the relationship between hours of sleep and liking for donuts? That's why we do a scatter plot like this. And we'll try and create, hey, is there a line that we can fit that would go up or down to indicate whether or not these things are related to each other? Now in this particular case, it's kind of hard to say that there is one, but there might be a slight increase of sleep with donuts. That's how you would do a scatter plot. We're not going to do a second stem and leaf plot because I don't want to. Instead, we are going to end with me just saying thanks, and we'll be done.